Let's take a look at a stranger kind of problem. Let's deal with some rational expressions. And we haven't been talking about the domains, but we need to talk about the domains of the composition. And the problems we've done up until this time, the domains, we haven't had to worry about them because the domain was pretty much all real numbers. But there are certain kinds of compositions where you do have to concern yourself with the domains. Let's take a look at the function 1 over x minus 1 and the function g of x, which is going to be 1 over x. And let's form the composition f circle g of x. And let's talk about the domain of the composition. Let's find the domain. All right, so what does f circle g of x mean? It means f of g of x. So the outer function is the f function. And so we're going to take 1 over the argument minus 1. Now the argument is going to be g of x. And g of x is represented by 1 over x. Now let's stop right here and think about the restriction on x. The restriction on x is such that x cannot equal to 0, because that's not defined in g of x. So we have right away got to restrict x to not equal 0. Because if x is 0, we're dividing by 0 here, and that's an undefined expression. So x cannot equal to 0, because 1 over x would not be defined. Furthermore, we have to have this entire denominator not equal to 0. Because if that entire denominator is 0, we're dividing 1 by 0. So we say 1 over x minus 1 cannot equal to 0. So that means that if we look at this, x cannot equal to 1 as well. So there's a couple of restrictions on our domain that has to be taken note of. X cannot equal to 0, and x cannot equal to 1. With those restrictions in mind, let's simplify this expression. All right, to simplify this expression, it's a complex fraction. To simplify a complex fraction, we multiply numerator and denominator by x, which is the lowest common denominator. So if we multiply by x here and by x here, we're going to get x in the numerator. And if we multiply by x here, we're going to get x times 1 over x. We're just going to get 1 minus x. Now the final answer, it looks like we only have one restriction, that x cannot equal to 1. But remember, we also have to exclude the x not equal to 0, because in the original expression we have 1 over x here. So there's two restrictions on x that we have to be mindful of. X cannot equal to 0 and x cannot equal to 1. Now let's look at the reverse composition, and instead of f circle g, we'll do g circle f and look at its domain. So what is g circle f? Well, g circle f, the outer function is g. So what I'm going to do here is write g. G is 1 over blank. So this means g of f of x. So it's 1 over f of x. Now f of x itself is the function 1 over x minus 1. Now here we have a restriction that x cannot equal to 1. Because if x equals 1, you divide by 0 in the denominator. And the entire denominator cannot be 0, but in that case, are there any numbers of x which will make this thing 0? And the only thing that would make it 0 is if the numerator is 0, but the numerator is 1. So there's no numbers that will satisfy that equation, so we don't have to worry about that. So the only restriction we've got to worry about here is x not equal to 1. Now again, let's go ahead and simplify this complex fraction. We can simplify by multiplying by the reciprocal of the denominator. And as we multiply by the reciprocal, we're going to get 1 times x minus 1 over 1, which is simply x minus 1. And again, the restriction is x is not equal to 1. So here again, we have an example of a composition in reverse order, and they don't equal each other. And so we have domain restriction.